Yeah, welcome back to my class again today. Now we've looked at the three types of error that you can find in programming languages. So we are looking at Python. So we've seen syntax error, we've looked at logical error, and then we've also seen runtime error. Now looking at that flow where we have the runtime error, how do you handle it? We've seen what happened at syntax error. The program will not execute because it's at the passing stage. Now, logical error, you have to keep testing your program for you to get your expected output. Now, runtime error is while the program is running, something from outside as the parameter supplied can trigger a problem. Now, you don't want your program to crash. You want that error to be displayed on the screen, and then you continue your process flow by capturing that error and correcting it. So what we want to look at now is how do you capture your error at runtime? How do you handle that runtime error? So Python has two features that it uses to capture this runtime error. The first one is what? Exception handling. And then the second one is what? Assertion. Now we are going to look at that exception handling in this class. And then in later class, we will look at assertion. So that is what? Exception. Now, exception handling in Python is done using some blocks. The first one is what? The try block, right? The second one is what? Exception block, right? Uh, we also have the S block, and then we have the finally block, right? So we are going to look at these four: the try exception block, the S block, and the finally block. That is what we want to look at as a way to handle runtime error. So the first one now that we'll look at now is this. That's what we want to look at in this class. So without wasting much time, the program that we wrote, which is what? Data variable mass calculation. Then the last part was what? Runtime error. So I'm going to show you in this class now how to capture that error and display on the screen, and not the way you saw it when we did it on PyCharm, which is what? Crashing the program. So I'm still going to define that function, and then I'm going to use that same mathematics. So I will say def variable math A, B, C, D, right? Now, I want a situation where if there is no error, the result should be printed out on the screen. But if there's an error, then the error message should be displayed, right? So the first thing I will do is I'm going to create a variable result. I will define this variable result and I will set it as what? None. Meaning if there is no result, there is an error, it will return result as none. Then it will display what? The error message on the screen. It will not crash the program. I will come here and I will say try. So I'll first create this try block. Now inside this try block is where I'm going to put my what? My calculation. So I will now say result, which is this result that I've set to none before. And then I will say A divided by B multiply, then C plus D. So I'm putting it inside this try block, right? Then I will now come here and I will say except 0 division error, right? Now, this 0 division error is a built-in error, right, in Python. At a later class, I'm going to show you how to create your own error class. So this zero division error, because the last class you saw it, that Python raised this error, zero division error, as the runtime error, right? When you were going to divide by zero. So I am saying, should there be a time that somebody is going to supply a parameter that will cause this, my calculation, to give you zero as the denominator, right? Instead of crashing the program, display this error that I want to write. So I will come here and I will say, except zero division error, print error, right? You cannot divide by zero, right? I want this error message to be printed out. So, okay, then I will now come here and I will say return result, right? Now, this is my function that I've written. This is my function. Now, I have written my function. So what I want to do now is I want to call this function, right? And then I'm going to supply external parameters to it. So I will now come here and I will say print, right? Viral math. And then I will supply 8, 0, 2, 2, right? This is what, so I'm calling this function, then I'm supplying this. Now what will happen? This A to be given to B, 0 will be given to A to be given to A, 0 will be given to B, 2 will be given to C, and this other 2 will also be given to what? To the D. Now it will come in. It will set this result to none. Now it will go into the try block. Inside this try block, it will execute this program. So what will it do? It will assign this 8 to A and 0 to B, 2 to C and 2 to C. It will carry out this mathematics. As soon as it does that, this will become 0, right? When it tries to divide, it will give you zero division error. This error, which will be raised here, this zero division error will be raised at this point. The system will throw you an error. So once that error is thrown, instead of crashing the program, it will pass control to this except block. So this except will catch this error that it will raise. This place will raise the error. This except block will catch it. Once it catches this error, it will now print out error. You cannot divide by zero on the screen. It won't crash your program. That is what will happen. So at that point, you now see that, okay, you go back to your parameter and discover that this value that you are supplying is the problem. Then it will return what? Result. It will return none. So it will print error. You cannot divide by zero. Then it will return none. Because that's what I want. So if I change this, so if I come here again and I say print viral math, right? And I supply 8, 2, 2, 2. This one will close here. Now, this one will come here. It will calculate the value and it will store it in result. Since there is no error, it will bypass this block and it will come here. It will return result as what? This one will return result 16, right? Why this one will what? Print out this. That is what will happen. So with this try and except block, I've been able to capture the error and then make it display on the screen without crashing my program. So that is what I have done here, how to handle error in Python. So that is the first part. So let's go to the PyCharm. Let me run this program for you to see. And in the next class, we'll now look at try except else in the next class. So let's go to the PyCharm. This is our PyCharm. So let's create the first one. So the first one will be try exception block try exception.py, right? Okay, so this is it. So we are going to define um, viral math, right? And then I'm going to supply A, comma B, comma C, comma D. And then here I'm going in. So here now I'm going to first declare a variable and assign none to it. So result, and then I will assign none to it. Then I will come to my try block. So this is my try block. And inside this my try block, I will now say result, and I will assign A divided by B multiply, then C plus D, right? And then I will come here and I will say except 0, so that is already it. 0 division error, enter and print out error, cannot division by 0 is not allowed. Division by 0 is not allowed. Then I will come here, right? So this is my program. Now, once it raises the error, it will capture it. So here I'm going to call this my var math. So I'll say print var math, then I'll supply 8 divided by 2 divided by 2, as in comma 2, sorry. So I'll just copy this and I'll paste it here and I'll change this one to 0. 0. So this is it. This is my function that I've written. And then I'm putting my calculation under the try except block, right? So I will supply 8 to this A, 2 to this, like that. Then it will go in and carry out this calculation. If there is an error, it will print out this instead of crashing, right? So I will execute this. Now look at this. In this place, I can explicitly return result, right? And I'll execute it again. So that is it. Because I'm saying that if there is no error, return result. Initially, it's return none. That's why I had to put this explicitly returning result. So when there is the calculation and there is no error, it will assign that value to what? To result. And then it will bypass this exception block. And then it will come to this return and it will return result back to this calling function. And then it will print out the result on the screen, which is what you are seeing here, 16.0. All right. Then this other one will run. At that point, it will throw you an error, which is what? 0 division error. Once the error is thrown, this except block will catch it. It will catch it and then go in and print out this. Instead of crashing, it will print out error. Division by 0 is not allowed. Then it will now return none, which means this none has not changed. This result has not changed. It's still having none. So this one will return none. So that's why you are seeing that this first one it's going to print out 16, right? Let's say I comment this. If I comment this out and I execute, you will just simply see it to print out 16, right? While this one, if I comment this one will print out division by 0 is not allowed. And then it will print out the result, which is what? None. So it will capture this first error, this one, and it will throw division by 0 is not allowed, while it will return none to the calling function, and it will print out the none you are seeing. So that is how you handle exception in Python, by using the try except block, right? So in the next class, I'll be showing you the try except else block. So till then, bye-bye.